Hello viewers, welcome back to my channel Emilia Online Maths, where we make maths easy and simple for students. So in our previous video, we introduced differentiation, the concept of differentiation, basic functions of differentiation. So today we are going to start with rules for differentiation. Like I said in the previous video, that this is the continuation. The next video will be the continuation, follow up of what? Of differentiation. So we are going to be breaking it part by part. So this is part 2 of it. So now let's go. Before I go on, if in case you have not subscribed to my channel, please, I would like you to do so. Emilia Online Maths. Please don't forget to drop your comment. I need your comment. I need your like. Please always click the like button. Don't forget to drop your comment. Now let's go. Some of the rules for differentiation, we have sum and difference rule. So let's start with sum and difference. Sum and difference. So in sum and difference, if y is equal to u plus v, where u and v are function of x, where u and v are functions of x, where they are functions of x, what we need to differentiate it, we have that the y over the x is equal to what? D bracket u plus v all over the x. This simply means, because they are sharing single denominator, that the u over the x plus the v over the x. The u over the x plus the v over the x. So this is called sum rule. This one is sum because it's plus, while so this one is sum rule. Why the rule for difference? Why the rule for difference is what? We have that the y over the x is equal to what? D bracket u minus v all over the x, which is what? The u over the x minus the v over the x. So now let's look at some examples. These are the formulas for sum and difference rule in differentiation. So example, let's look at some of the examples. Find the differential coefficient of the following function. Find the differential coefficient of the following function. So the first one stated that y is equal to x to the power 5. Y is equal to x to the power 5 x to the power 5 plus 4x to the power 3 minus 5x plus 4. X to the power 5 plus 4x to the power 3 minus x minus 5x plus 4. So what do we do in a situation like this? We have to apply the rule. if you look at this question very well, you discover that we have sum and difference. You discover that we have sum and difference, okay? So what do? So we now say that what? Applying the rule. So to apply the rule, I have that the y over the x is equal as what? D bracket what? X raised to power 5 plus 4x raised to power 3 minus 5x plus 4 all over dx. Minus 5x3 plus 4 all over the x. Okay? So this one is sum. We are going to be breaking it. This one is sum. We are going to be breaking it. That simply gives us what? That d over the x bracket what? X to the power 5 plus d bracket what? 4x to the power 3 over the x minus d bracket 5x minus d bracket 5x over the x plus d bracket 4 over the x plus d bracket 4 over the x. Okay, recall that what? One of the what? Basic functions, that when the y over the x is equal to 0. Now when the y over the x is equal to 0, the constant is equal to 0. So this is the constant. This constant will tend to be what? 0. So we now have that what? That the y over the x is equal as what? We start differentiating. So we are applying the formula for differentiation, that y over the x is equal to an x raised to power n minus 1. So where n will multiply the coefficient and the power of n will be reduced by 1. So we start applying the formula. That is what we mean by differentiating. We'll start differentiating, okay? So that the y over the x will now be what? You know that the first function is what? X raised to power 5. So it will now be what? 5x raised to power 5 minus 1 plus this one will now be what? 4 times 3. Okay, 4 times 3 x raised to power 3 minus 1. Okay, minus 5x raised to power 1 minus 1 plus 0. That is the constant. So this one will leave us with what? That 5x raised to power 4 plus 12x raised to the power 2 minus 5, because x raised to power 1 minus 1 is x raised to power 0, and anything raised to power 0 is what? 1. Okay, so we have now differentiated it, stating that the y over the x is equal to 5x raised to the power 4 plus 12x raised to the power 2 minus 5. Okay, now let's look at another example in sums and product, in sums and difference. Let's look at another example. Okay, the function y is equal to what? 3x raised to the power 5 minus 2x raised to the power 3. You can see that their degree of power must what? Or power of x will decrease, plus x to the power what? 2 minus 6. So this is a function, this is a function, this is a function, this is a function. So all we need to do is what? That the y over the x, applying the what? The formula. So this one is what? Difference, and this one is what? Sum. I can solve together to give me what? That d bracket what? 3x raised to the power 5 over the x minus d bracket what? 2x to the power 3 over the x plus d bracket what? X to the power 2 over the x minus d bracket what? 6 over the x, stating that I am differentiating 6. Then applying that what? The function rule, that when the y over the x is equal to is what? Bracket the function, it is equal to 0. Okay, so now we start differentiating. To differentiate this, I have that what? 5 bracket what? Or 5 multiply 3x to the power 5 minus 1 minus what? 3 into 2x to the power 3 minus 1 plus 2x to the power 2 minus 1 minus 0, because I have differentiated this one applying the function. Okay, so I have 15x to the power 4 minus 6x to the power 2 plus 2x to the power 1, and anything to the power 1 is what? That. So you can see that the y over the x is equal to this. So this is about sum and what? Rule. Now let's look at the products, sum and difference. Sorry. So now let's look at the product rule. Product rule stated that what? In product rule, or let's look at one more example applying the what? Trigonometry with what? Sum and differences. Okay, so look at the next example. So you said that we should what? Find the derivative of the function y equal to 6x to the power 3 minus cos x plus 5 sine x minus 2 e to the power what? 2 exponent. Okay, so we have that what? That the y over the x is equal to what? Just like we did in the other one, d bracket 6x to the power 3 over the x minus d bracket what? Cos x over the x plus d bracket 5 sine x over the x plus d over the x bracket is minus d bracket. So this one is minus d bracket over what? The x bracket 2 exponent. Okay, then that will leave us with what? We start differentiating. This one is what? That 6 is multiplying 3x to the power 3 minus 1 minus, when we differentiate cos x is what? Sine x, minus bracket minus sine x, we just substitute it with the what? Okay, plus what? 5 cos x, and recall that sine x is equal to what? Cos x. 5 cos x minus 2 e to the power what? X. Okay, so we'll now open or simplify this into this will give us 18x to the power 2 minus into minus will give us plus sine x plus 5 cos x plus 5 sine cos x minus 2e to the power x. Okay, so this is the differential coefficient of what? This. So now let's look at the what? Product rule. Let's look at the product rule. So in product rule, we stated that what? We said that if y is equal to uv, that is u times v, where u and v are both function of x, where u and v are both the functions. So then we have that the y over the x will now be equal to what? D bracket u plus v over the x. D bracket u, which is what? U, which is u dv over the x plus v du over the x. So these are the functions, u to the product of what? Dv over the x, and v to the product of the u over the x. So this is called the product rule. Okay, so now let's look at some examples from the product rule. Examples. It says find the derivative of the following functions using product rule. Find the derivative of the following functions using or applying product rule. So applying product rule, so these are the functions. Now y is equal to what? 2x plus 1 and what? X squared plus 2. So the next one is what? That y is equal to x squared sine x, x squared sine x. So the next one is what? That y is equal to x squared plus 2x minus x squared, bracket 3x plus 2 and what? X squared minus 4. X squared minus 4. So applying the what? Product rule. So you can see that this one is what? U and this one is V. I will now say let U be what? In number 1. In number 1 or number 1A. So let me state it so I will know the ones that we are solving. I'm picking it one so that I don't get confused. The one we are solving and the one that we are not solving. Okay. So let's continue. So solution to A, having that y is equal to the product of 2x plus 1 and x squared plus 2. So the solution to it will now be what? That u will be what? 2x plus 1 is a function, and v is equal to x squared plus 2, another function. So note that what? That the u over the x is equal to 2. The u over the x is equal to 2. The u over the x is equal to 2. So differentiation of what? To differentiate u, we have 2. To differentiate v, we have, and also that the v over the x is equal to what? 2x. How? So this one is our what? u. Let's take it bigger so that you understand it. That the u over the x is equal to, let me differentiate this to u. So I have 2, the power is 1, 2x 1 minus 1 plus 0, because the last constant, the constant is what? 1. So I will differentiate it, leaving me with what? 2x raised to power 0. And anything raised to power 0 is equal to 1. That is how we got 2. Okay? So now the same thing is applied in what? The v over the x. So having that what? X squared plus 2 will leave us with what? 2x to the power 2 minus 1 plus 0, because the constant is 0, giving us 2x. Now that we have known how we differentiated u and v, so we call it the u and the v. Okay, we start applying the function, and the function says that what? That the y over the x is equals to what? U dv over the x plus v du over the x. So where is our u? Our u is what? 2x plus 1. We now say 2x plus 1 is multiplying, 2x plus 1 is multiplying our dv is x, the 2x is multiplying 2x plus, what is our v? Our v is x, look at it, our v is x squared plus 2. So okay, we have that x squared plus 2 is multiplying our du is 2. Differentiation of u is 2. So this is how we are going to arrange it. So we start expansion. So this into this will give us 4x squared plus 2x plus 2x squared plus 4. So in expansion to this, okay, so this is what we have. We start arranging them to the degree of their powers, okay. 2x squared, 2x squared, we'll bring it together, we have 6x squared plus 2x plus 4. So this is what we have, that the y over the x will now be what? This. Okay, so now let's conclude by what? Solving this. Y is equal to x squared sine x. In the next one, that y is equal to x squared sine x, so that the y over the x is equal to u dv over the x plus v du over the x. So which one will be our what? We'll now say let our u be what? X squared, because this simply means that what? In this function, to expand it, I have that x squared is multiplying sine x. Okay, this one is our u and this one is our v. I hope it's clear now. Okay, and also our v be what? Sine x. So with that, we begin to go. Recall that what? That the sine x over the x, one of the function is equal to what? Cos x. Don't forget that. Okay, so now we begin to what? Apply the function. Okay, having that u dv over the x, so the y over the x will now be what? X squared. Okay, that is u dv over the x plus v du over the x. Our u is what? X squared. So I have x squared bracket. What is our dv? Our dv is what? Cos x. Differentiation of sine x is cos x. So cos x plus What is our v? Our v is sine x. Sine x is multiplying. What is the differential coefficient of what? Our u. That is x squared. To differentiate it, we have 2x. Okay, so when we open the bracket, what do we have? We have x squared plus x plus 2x sine x. x squared plus x plus 2x sine x. Okay, so that is what our dy over the x. So the last one is what? That y is equal to what? 2x minus 1 and what? X squared plus 1. 2x minus 1 and x squared plus 1. Okay, having that the y over the x is equal to what? D bracket what? U plus v over the x. Okay, u dv over the x plus v du over the x. So let's our u be what? 2x minus 1 and our v is what? X squared plus 1. So we begin to apply. Now let's find the u over the x. Since we want to differentiate this u, we have what? That the u over the x is 2. Because if you differentiate this, you're getting 2. The last number there, the last one there is what? Minus 1, so it's a constant. So now let's differentiate v. The v over the x is what? 2x. Just like we did in the other one, is 2x. Okay, so what do we have? We now have that what? That the y over the x being equal to u dv over the x plus v du over the x will still land us to the same. So our u is what? 2x minus 1, 2x minus 1, and our dv is multiplying 2x plus, okay, our v is what? X squared plus 1 is multiplying 2, our du. So when you open the bracket, I have 4x squared minus 2x plus 2x squared plus 2. Okay, so I have this into this. Okay, 2x squared. Okay, so I have 2x squared minus 2x squared plus 2x squared. Let's check something. So this into this. No. So I'm having this into this will give us 4x squared. This into this will give us minus 2x, okay? Plus this into this will give us plus 2x squared. This into this will give us plus 2. So when I bring it together, I have 2x squared plus 2x squared minus 2x plus 2. So leaving me with was 6x squared minus 2x. 6x squared minus 2x plus 2. Okay, so if you like this question, please, I would like you to what? Click the like button. Don't forget to subscribe to my channel for more videos. See you in our next video. My channel, Emilia Online Maths. Always make sure, because I will be updating you with questions and solving. Okay, always make sure that you subscribe to my channel, click the like button and share the video. Bye bye.